Hello, my name is Brian Niels. I'll be presenting section 5.4 of the geometry textbook, which is mainly about medians and altitudes in a triangle. Now, a median is essentially a line that cuts through the vertex of a triangle and intersects at the midpoint of the side adjacent to it. And an altitude is a line perpendicular to one side that shows the height of the triangle. And in this triangle right here on number 21 of this section, we have two triangles side to side, and our given information is that triangle XYW is congruent to ZYW, and we have to figure out what line YW is. Now we have four choices. We have that it's a perpendicular bisector, an angle bisector, a median, and an altitude. So we have to use the given information to figure out what type of line this is. So because we know these two triangles are congruent, then we can already rule out that these two angles are congruent as well. And this is congruent to itself, and these two angles are congruent too. And also these. And also, you know, these two sides are congruent, and these two sides are congruent. Now, that tells us a lot, because we know that basically these two triangles are congruent, so every angle that corresponds to each other will be the same. And because we know that these two angles are congruent, and they are also a linear pair because they lie on the same line, we know that each angle can only be 90 degrees because a linear pair adds up to 180 degrees, and those two angles are supplementary. So we know that YW is a perpendicular bisector. Because these two angles are the same, and the side that it intersects both have, like, it intersects at the midpoint, so both sides are congruent. So that means it's a perpendicular bisector. And it's also an angle bisector because the angle that it intersects here creates two congruent angles on either side. And because it's also a perpendicular bisector, we know it's an altitude because every altitude intersects the side at a 90-degree angle and also shows the height of the triangle. And it's a median because it intersects the midpoint of the adjacent side through the vertex of the top triangle. So, because we figured out that both triangles are congruent, we know that YW can be all four choices because, like, by ruling out, you know, the, like, everything that it could be, we figure out that it is all the choices.
Today I will be showing how to do lesson 5.5, the use of inequalities in a triangle. When doing this lesson, there are two key terms that one must know. First is side opposite, which is a side or length that is directly across the given angle in a triangle. For example, in a right triangle, the side opposite of the 90-degree angle is the hypotenuse because it's directly across or opposite the angle. The second key term is inequality, which refers to an equation that uses the less than symbol and the greater than symbol as opposed to using the equal sign. Great, now that we have that, we can start with the theorems. The first theorem is theorem 5.10, which states if one side of the triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. For example, take triangle ABC. We'll make side AB 8 and side BC 5. So AB is greater than BC. Because AB is greater than BC, the angle opposite AB is greater than the angle opposite BC. In this case, angle C is opposite of AB, and angle A is opposite of BC. So that means the measurement of angle C is greater than the measurement of angle A. Got it? Good. Our second theorem is theorem 5.11, and it basically the opposite of Theorem 5.10. It states that if one angle of a triangle is larger than the other angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Here's what I mean. Further explain what I mean, let's use triangle XYZ. We'll make angle X 50 degrees and angle Z 75 degrees. The measurement of angle Z is greater than the measurement of angle X. Because angle Z is greater than angle X, the side length opposite Z is greater than the side length opposite X. In this case, the side length opposite Z is XY, and the side length opposite X is YZ. That means the side length XY is greater than the side length YZ. Our last and final theorem is Theorem 5.12, or the triangle inequality theorem. This one states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Here's what I mean. Let's take triangle EFG. According to Theorem 5.12, adding any two sides of this triangle will be automatically greater than the third side. So if you add side EF plus side FG, it would be greater than side EG. The same goes with if you add EG plus EF. It'd be greater than FG, as well as adding EG plus FG, it'd be greater than EF. Now that we've finished discussing the theorems, it's time to move on to some practice problems. For our first practice problem, we'll be utilizing Theorem 5.10. The problem states, list the sides and angles in order from smallest to greatest. Here we have triangle JKL, where the side lengths are already labeled. So we know that the shortest side length is opposite of the smallest angle, and the longest side length is opposite of the largest angle. So in this case, the smallest side is KL. So we put that one first, being at 13. Second is JL. And then it's KJ, or JK. Since KL is the smallest, we know that opposite of it, there is the smallest angle. So opposite of KL is J. So J, angle J, would be the smallest. Then opposite JL here would be K, that'd be the next. And then opposite the largest side, JK, would be angle L. Our second practice problem involves Theorem 5.11. This is the same concept as the last practice problem, although we are given the angle measurements as opposed to given the side lengths. We do have to add an extra step, however, seeing as though we don't have angle measurement M. We do know that all the angle measurements of a triangle add up to 180 degrees. So that means angle N plus angle P subtracted from 180 will give you angle M. 127 plus 29 equals 156. 156 subtracted from 180 equals 24. The measurement of angle M is 24 degrees. Now that we've deciphered all the angle measurements, we can determine which side lengths are longer and which one are shorter. From this theorem, the shortest side length will be the opposite of the smallest angle. So we can assume that because NP is opposite angle M, then NP would be the shortest side. The second biggest angle is angle P. That would mean the side length opposite would be the second largest. So angle P, the side length opposite angle P is MN. Last but not least, the largest angle is opposite the largest side. So 127 is opposite MP. And then we can just say the smallest angle M, angle P, and angle N. Our last practice problem is from Theorem 5.12. The question states, is it possible to construct a triangle with the given side lengths? So, real quick, I'm just going to draw my triangle just for a diagram. And then we're going to make this 9, 6, 3. It's not drawn to scale, obviously. The question is asking if, using this theorem, is it possible for these three lengths to form a triangle? Well, first we have to implement what this theorem is saying. So this theorem states you can add any of the two sides, but the sum has to be greater than the third side. So we will try 9 and 6. 9 plus 6 equals 15. 15 is indeed greater than 3. We will try 3 and 6. 3 plus 6 equals 9. Now, 9 is, of course, not greater than 9, but in fact equal to 9. For this to be a triangle, these two sides would have to be added together, would have to be greater than 9. So these three side lengths do not make a triangle. So, not a triangle.
To write an indirect proof, you have to identify the statement you want to prove. Assume temporarily that the statement is false by assuming that its opposite is true. For step 2, you reason logically until you reach a contradiction. And for step 3, you point out the desired conclusion. It must be true because the contradiction proves the temporary as assumption false. You reach contradiction when you have two statements that cannot be true at the same time. An indirect proof. Theorem 5.13 talks about the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is longer than the included angle of the second, then the third side of the first is longer than the third side of the second. Theorem 5.14 talks about the converse of the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. Then you have indirect proof. A proof in which you prove that a statement is true by first assuming that its opposite is true. If the measurement of angle ABD is greater than the measurement of angle CB, which is larger, AB or CB? In this case, AB is longer. 2. Suppose you wanted to prove that the statement, if x plus y does not equal 5 and y equals 2, then x does not equal 3. What temporary assumption could you make to prove the conclusion indirectly? You can temporarily assume that x equals 3.
Thank you so much for tuning in. I hope this really helped. And that's it. Bye!